Okay, welcome back. This is part 2 of lesson 1, and in this lesson we're going to look at slope fields. Now, slope field is a visual representation of a solution of a differential equation. Now, to be honest, this is one of my least favorite topics in calculus, although it's probably the easiest. However, when I was in school, there was no slope field. We didn't talk about slope field, so that's probably why it's not one of my favorite. But it's a very simple topic. Basically, if you think about dy dx is equal to x, then if you integrate that, you would get x squared. So think about what the function would look like when it's integrated. And x squared produces parabolas. So the slope field, if you look at the slope field, you can look at it and tell it's going to look similar to parabolas. So we're seeing dy dx is equal to x. But y, if we integrate that, we get y is equal to 1/2 x squared plus some c. So all the sketches in red just represents possible solutions to this slope field. To create a slope field is very easy. We're going to start by creating an xy dy dx table. Then we're going to sketch a line segment estimating the slope. Now, this is just an estimate. So when I sketch a slope that a line segment that has a slope of 3, I'm not going to measure it. I'm not going to get a protractor out and make sure it has a slope of 3. I just want to make sure that when I sketch a slope of 2, that it is not as steep as my slope of 3. So it is an estimate. So the way we would do this, we're given the dy dx here. So we're given dy dx is equal to x minus y. So I'm going to set up an xy table with dy dx. So when x is -4 and y is 2, I get -4 minus 2, -6. And notice I just grabbed some random values of x and y here. These are just very random. When x is -2 and y is 0, I get -2. When x is 0 and y is 4, I get -4. When x is 2 and y is 4, I get -2. 4 minus 6, -2. 8 minus 8, 0. So I just grabbed some random values for x and y, and I'm going to graph those, and we're going to see if we can't find a pattern. So when x is -4, oh, I don't even have that on here, so I have -1, 2, 3. I don't have -4, but when x is -2 and y is 0, that would be at this line, and I get a slope of -2. So a slope of -1 is about 45 degrees, so a slope of -2 is slightly steeper, so I'm going to kind of sketch what a slope of -2 would look like. When x is 0, and again, I don't know why I chose those numbers because that's not on here. Let me do this. Let's do x is 0 and y is 3 would give me -3, so it's going to be steeper than this one, so I'm just going to kind of sketch it, be -3. When x, I can't do 2 and 4. I can't do any of these. I don't even know why I chose those numbers. Let's just choose some points here. So when x is -3 and y is 0, I get -3. So this was -2, so this is going to be slightly steeper. So I want to make that a little bit steeper. When x is -1 and y is 0, I get -1, so that's going to be about 45 degrees, so it's going to look like that. When x is 0 and y is 0, I get 0, so that would look like that, just the slope of 0. When x is 1 and y is 0, I get a positive slope of 1, so that's going to be about the same steepness as this, but positive, about 45 degrees. When x is 2 and y is 0, I'm going to get a steeper slope at 2. When x is 3 and y is 0, my slope is a little bit steeper than this one, and so it's going to look like that. And I know you're saying, what is the purpose of that exactly, which is why it is not one of my favorite things to do, because I can't see its purpose. But it's really easy. So when x is 0 and y is 1, I get a slope of about -1. When x is 0 and y is 2, I get a slope of negative 2, so it's going to be slightly steeper than that one. And that's pretty much what it is. It's just sketching these line segments. It's very tedious, and that's it. So I'm not going to complete this. If you are so inclined, you can complete those and just grab points and see what it's like, and just plug them into the formula and sketch them. So you can see some patterns. So for instance, for this one, dy dx is equal to x plus 1, I would expect when I'm done for this to look sort of like a parabola. So I'm just going to kind of grab some, I'll probably do like a 2 by 2 area and just kind of see what it looks like. So if I have x is 0 and y is 0, I'm going to get 1. Then dy dx is 1. So if x is 1 and y is 0, I get dy dx is 2. If x is negative 1 and y is 0, I get 0. So just kind of sketching that, I get when x is 0, y is 0, I get a sketch of 1. At x is 1 and y is 0, I get one that's slightly steeper. If I go to negative 1, I'm going to get a negative 1 here. No, I get 0. I'm sorry. I get 0 there. Sorry. I get a 0 here. Let me change that to a different color so we can see. I get a 0 here. Notice that in all of these, I'm going to get a 0 because y is really not affecting this graph since it's only affected by x. So when x is negative 1 and y is 2, I still get 0. So all of these are going to be 0. And that's kind of what, when you're graphing these, you kind of want to look for the patterns. Also for these, because y is not affecting them, all of these will be 1 here. And all of these will be 2. So these should be parallel. Here, when x is negative 1, when x is negative 2, I get negative 2, and y, doesn't really matter what y is, I get negative 1. So the graph here would look like this. And you can kind of see you're going to have sort of a parabola looking thing here. So if I were to sketch this out, it looks sort of like a parabola. If I were to draw a slope bill through it, I would sort of get a parabola. If I had done that better. But you have in your vertex here at 0. When you're sketching a slope fill, the thing is you can't go through a slope fill. You can't draw through a line. So you kind of traced around it. So that is what that would look like. Now in this one we notice that x is not affecting it. Okay? So my x value, doesn't matter what my x value is because it's not part of this, it's just going to look like the y. So if I just do a simple xy table, it's probably better to get a different color. xy, dy dx. So let's say x is 0 and y is 0, I get 0. X is 1 and y is 0, look, I still get 0 because x isn't affecting it. So let's do some with, I'm changing y. When x is 0 and y is 1, I'm going to get 2. So we see that our slopes are going to be parallel in this direction. So when x is 0 and y is 0, I get 0 slope here. So I have a 0 slope here as long as y is 0 on all of these. So all of these will have a 0 slope. Okay, here y is 1, so my slope is going to be 2. And you'll see that my slope is 2 for all of these. So I'm going to kind of make that a little steeper than I would if it were 1. My slope would be 2 for all of these, so these will all be parallel to each other. When x is 3, it's going to be 6, so that's going to be even steeper. That's almost like a straight line, if you will. But all of those would be parallel to each other. When y is -1, I get a slope of -2. So that would look like this. All of these would be -2. So they all would be parallel in this direction because x is not affecting it. So, and then I would get a -6 here, so it's going to be almost perpendicular, but with the slope of -6. So what would my slope field look like for this? I kind of follow the flow. So my slope field for this would kind of be a sideways parabola. Kind of, maybe, sort of. Kind of look like that. I know it's pretty ugly. But no, it wouldn't look like that because this would be 0. I'm sorry, that's not right. My least favorite thing to teach. Because you're going to have a slope of 0 when it goes to 0. So I think it looks sort of, not sure what that looks like. We could integrate it and see. But that's pretty much what you would do to find the slope field. Okay, this one, both x and y are there. I think this may look like a circle, but I'm not sure. So we just grab some points. 0, 0. I get 0, 0. X is 1, y is 0, I get 1. X is 2, y is 0, I get 2. So it's a little bit steeper. X is 0, y is 1, I get 1. X is 1, y is 1, I get 2. So it's a little bit, so it's going to look like they're mimicking each other diagonally, because like these were both 1s. So when x is 0 and y is 2, that's going to be a 2 as well. So we can see that they're sort of parallel in this direction. Let's see if that works here. When x is 3 and y is 1, we get y is -1, so that'll be 2 as well. Okay? And so here, when x is -1 and y is 0, I get -1, -2, which is a little bit steeper, and -3. It kind of gets hard to measure them when I probably made that one too steep. It's kind of hard to follow that. And that's basically what you do. You just keep making these little line segments and sketching your graph. I know that probably wasn't the best lesson, but we will go over this again tomorrow. We have a few more to do, but it's basically the same thing. You're just going to kind of ignore that. We won't get to that until next unit. But just kind of make your little slope field based upon this. And so you can practice this, and we will talk about it tomorrow.